Hey YouTubers, we're gonna look at another example of redox reactions in terms of electron gain and loss. And this time we're gonna talk about a reaction, a displacement reaction, that is a redox reaction that happens in solutions. And this will make our lives a little easier. Okay, I have an example where I have zinc reacting with hydrochloric acid, getting me zinc chloride and hydrogen gas. And immediately what you noticed is that we have aqueous or solutions in this equation. And whenever you think of aqueous solutions, you can immediately kind of think of ionic equations as well. And in ionic equations, what happens is that the aqueous solutions will break apart. These substances, when in water, it will ionize. Or this will dissociate completely, and this will ionize completely because this is a salt, and this is not a salt. Okay, so what happens when it dissociates completely? Well, we'll write down the substances that does not break down. Okay, so zinc did not break down, but hydrochloric acid did. All right, hydrochloric acid did, and it broke down into a proton or hydrogen ion. And it broke down into chloride, okay? And the zinc chloride here broke down into zinc ions and chloride ions. Now notice that in the original formula for zinc chloride, the subscript, the number of chloride in here is 2. And it's written in the bottom right corner of this formula. But when it becomes ions, suddenly the number 2 here is not written at the bottom right corner, but at the top here. Because zinc chloride is basically ions that is made out of zinc and chloride. So 2 chlorides with 1 zinc. And so in solution, what happens is that it breaks down into 3 pieces. So 1 chloride, 1 zinc, and another chloride. All right, so it breaks down into 3 pieces, and you take 2 of these pieces because they're the same thing, and you write 2 here. Okay, and it forms hydrogen gas. Fantastic. Now, looking at this equation, immediately you can determine that the spectator ions are the chlorides. And so this is what happens. You have your ionic equation to be zinc plus 2 hydrogen or protons, hydrogen ions or protons, forming a zinc ion, and hydrogen gas. And so looking at this equation, you can determine that something is oxidizing and something is reducing. Let's look at zinc changing to zinc ion. Zinc changed to zinc ion. All right? So the charge of this zinc here is 0. So let's put the cameras down a little bit. The zinc here, the charge is 0. The zinc here, the charge is +2. And so the charge on the left side of the equation is 0. The charge on the right side of the equation is +2. And the only thing you can add into this equation are electrons. So the number will get more, the numbers will decrease as you add more electrons on this side or that side. And you add electrons on this side because this is a +2, and you add 2 electrons to make it equal 0. So because the electrons are on the right side of the equation, we can say it's a loss of electrons. So zinc here oxidized. Okay? And let's look at the other equation where you have your hydrogen ions or protons forming to hydrogen gas. So again, because we have determined the oxidation reduction to be here, so immediately I can kind of determine that the electrons must be gained from the zinc. Okay, so zinc gave the electrons to the proton or the hydrogen ions to form hydrogen gas. So here, the protons here reduced. Okay? So that's another way to determine redox reactions in terms of electrons gain and loss.